Good evening, student. Today I will teach you about the P block elements. This topic is related to class 11th as well as in class 12th. As you know, in the periodic table there are 4 types of element classified on the basis of the blocks. One is S block, second is D block, third one is P block, and fourth one is F block element. So what is the meaning of the P block element? Dear student, when we will write the electronic configuration of any element and we find the last electron or differentiating electron enter in P subshell, they will be called P block elements. In the class 11th we have studied about the S block element. When the differentiating electron enter in the S subshell or S orbital, so they will be called S block element. So in the P block element, most of the non-metals are kept and they are generally called non-metallic element. Elements of group 13, 14, 15, 16, 17 and 18 are called P block elements. So dear student, first of all, group 13, group 14, group 15, group 16, group 17 and group 18 elements. These 6 groups elements are called P block element. In class 11th we study the group 13 elements and group 14 elements. This family, that's mean group 13 elements are called boron family, while group 14 elements are called carbon family. These two groups we study in class 11th, while in class 12 we have to study group 13, that's mean nitrogen family, group 16, that's mean oxygen family, group 17, that's mean halogen family, and group 18, that's mean noble gases, or you can say inert gases. So there are 4 groups which we have to study in class 12. Total elements of P block, that's mean group 13 to group 18, but we have already studied about the group 13 and group 14 elements in class 11th. So we will study now group 15 and 16, 17, 18 groups elements in class 12. Group 15 elements, that's mean nitrogen family. It contains nitrogen, phosphorus, arsenic, antimony and bismuth. These are the 5 elements, while group 16 also contain the 5 elements of oxygen, sulfur, selenium, tellurium and polonium. Now the group 17 elements: fluorine, chlorine, bromine, iodine and astatine. These are the 5 elements. And in the group 18, helium, neon, argon, krypton, xenon and radon. So as you are seeing here, 5, 5, 5, 15 and 6, 21. Detail of these 21 elements we will study here. So starting from the first group, that is group 15 elements. Okay students, so as you know there are the 5 elements in group 15. Dear student, the first element is nitrogen, then phosphorus, then arsenic, antimony and bismuth. So as you know, the first element as a member of the family This family is called nitrogen family, and nitrogen is the first member. It occurs free in nature as well as in the combined state. As you know that 78% of atmospheric air is nitrogen, and it occurs in the atmospheric air 78% as well as in the combined state in the form of Chile saltpeter or Bengal saltpeter and other combined salt. This is the 23rd most abundant element of the earth. Earth crust, it also contains in the earth crust, and the largest amount of the atmospheric air is nitrogen. Nitrogen is diatomic gas, and it is inert in nature, while the phosphorus is most reactive. That's why it does not occur free in nature. It occurs in the form of combined state like calcium phosphate or chloropatite, and it is the most important and the essential element of the animals and human being. It is present in the bones and the tissues of the animal. Nitrogen also is the vital part of the human being. It is present in the vitamins, proteins, DNA, RNA, and some type of amino acids. So these two elements of the family of group 15, they are most abundant elements. But the below element arsenic, antimony and bismuth, they are not very common. They exist in the combined state only in the form of the sulfide, and they have very less percentage in the atmosphere as well as in the earth crust. So dear student, now moving towards the electronic configuration of group 15 elements. The first element is nitrogen. Electronic configuration. Nitrogen is the first element. Its atomic number is 7, and we can write 1s2, 2s2 and 2p3. You are seeing the differentiating electron here enter in p subshell, and it is containing 3 electrons. That means it has the stable configuration because these have the half-filled p orbitals. Every group 15 elements have this type of configuration. After the nitrogen, the next element is the phosphorus, and its atomic number, phosphorus, atomic number 15, as you can write it Ne, 3s2 and 3p3. Next element, that is arsenic. And its atomic number will be 33. So it will be Ar, 3d10, 4s2 and 4p3. Next one is antimony, strontium. Antimony, and its atomic number is 51. So it will be Kr, 4d10, 5s2 and 5p3. After that, last element, that is bismuth, and its atomic number is 83, and it will be Xe, 4f14, 5d10, 6s2 and 6p3. What you are seeing, dear student, in all the electronic configuration, the general electronic configuration of the group 15 elements, all are having 2s2, 2p3, 3s2, 3p3, 4s2, 4p3, 5s2, 5p3. So we can say ns2, np3. Okay, students. Now moving towards the properties of the group 15 elements. As you are seeing, the first element is nitrogen. First of all, we will discuss about the physical state. Physical state. As you know that nitrogen is only a diatomic gas, it is the first member because it has smaller in size, and due to the p-pi bond and small size, nitrogen is in a gaseous state and it forms diatomic in nature. But phosphorus is easily vaporized solid, it can be converted into vapor, while other elements like arsenic, bismuth and antimony, these are completely solid. So first, that's if you want to conclude that what is the nature of the element present in the group 15. So what you will tell, nitrogen is a gas. And why it is a gas? Because it is a small in size and due to presence of p-pi bond. While in the phosphorus, p-pi bond is not present in the phosphorus, p-pi bond will be presented. So p-pi bond, and there is a larger in size, that's why phosphorus exists in the solid state. But phosphorus is easily vaporized into a vapor, and other elements do not undergo the vaporization easily and they are a typical solid state. Now the next point is atomic size. Atomic size, as you know, on moving from top to bottom, when we go from nitrogen, then phosphorus, then arsenic, then antimony and bismuth, what do you observe? It contains only 2 shells. Here there are 3 shells, 4 shells, 5 shells and 6 shells. As we are going downside, these are the number of shells. As we are going downside, number of shells are increasing, so the size of the group 15 element on moving downside will be increasing. Nitrogen is the smallest element, that means it is very small in all these 5 elements, while the bismuth is the largest one. If we compare between the group 15 element, this is group 15 and group 14 element, so on moving from left to right, the element size will decrease because of the nuclear charge increases. So element of the group 15 will be smaller than group 14, and the elements of group 16, if we compare from the oxygen, and here we are taking that is carbon. So dear student, what do you observe? Nitrogen will be smaller than the carbon and bigger than the oxygen. That means group 15 elements are smaller than 14 element group and larger than the group 16. But on moving from top to bottom, the atomic size will increase because the number of shells are increasing. Now moving towards the ionic radii, as we are moving from nitrogen to bismuth, nitrogen is a non-metal, phosphorus is also a non-metal, and arsenic is a metalloid, while bismuth and antimony and bismuth are showing the positive nature. They are 3 are formed negative, that means m to the power -3. Nitrogen form n triple negative, phosphorus form p triple negative, arsenic also form as triple negative, while the bismuth and antimony will form triple positive. So dear student, what do you observe? That means the negative ions has the larger size in comparison to the parent atom. That means n triple negative is greater than n, p triple negative is greater than p, as triple negative is greater than as, but sb triple positive is smaller than sb, and bi triple positive is smaller than bi. It happened because when any negative ion will be formed, number of electrons in the valence shell will increase and the attraction towards the nucleus and valence electron will be less. That's why the size of the negative ion will be greater than the size of the parent atoms. In case of the positive ion, what do you observe? Loss of electron will take place and the attraction between the valence electron and the nucleus will increase and the size of the positive ion will decrease. So antimony triple positive or Bi triple positive has the smaller size in comparison to their respective parent atom. Okay students. So students, now the most important property, melting and boiling points. You will feel this is the easy one, but it is the most typical property of the group 15 elements. Why it is very typical? As we move from nitrogen to bismuth, size is increasing because number of shell is increasing, but the melting point from nitrogen to arsenic will increase and then decreases to bismuth. That means we cannot say that on moving from downside, from top to bottom, from nitrogen to bismuth, the melting point is continuously will not increase. What happened when we move from nitrogen to arsenic, nitrogen, then phosphorus, then arsenic? Here they have the tendency to form the covalent bonds. They can form the 5 covalent bonds. While on moving towards the bismuth and antimony, what you see that due to the inert pair effect, that means they have less intra-atomic attraction between the two antimony or two bismuth atoms. The weak intra-attraction force due to the larger size, so melting point of antimony and bismuth will be smaller. Dear student, when we move from nitrogen, then phosphorus, then arsenic, what do you observe? The size will increase and they have tendency to form the covalent bond. But the tendency to form the covalent bond from antimony and bismuth will be lesser because of inert pair effect. Due to the inert pair effect, the melting point, that means the intramolecular or intra-atomic attraction force between the atoms of the antimony and bismuth will be smaller and they have less melting point. But the boiling points on moving from top to bottom will be remain same, because when the liquid will melt, then exactly it depends upon the size of the atom, and the size of the atom of bismuth is larger, so the bismuth has higher boiling points. So if we write the melting points, so nitrogen is less than phosphorus is less than arsenic. This is the correct order, but the arsenic is greater than bismuth is greater than antimony. This is the inert pair effect will be larger in the bismuth in comparison to the antimony. So bismuth has in comparison greater melting point than antimony. Boiling points order will be the same. Nitrogen is less than phosphorus is less than arsenic is less than antimony is less than bismuth. Now see this is the most important property. So what do you see here? Nitrogen is having the low melting point while the arsenic is having the highest melting point in the group 15 elements. Now moving towards the very important property, that is ionization enthalpy. Ionization enthalpy. That means energy required to lose one electron from the gaseous atom to form a gaseous ion. Dear student, in comparison to the group 14 elements, group 15 elements have extra high ionization enthalpy. Group 14 elements have high ionization enthalpy, but group 15 elements have extra high. That means if we move from left to right, ionization enthalpy increases, but the increase from group 15 to group 14 to group 15 is very large. If we see the group 15 and group 16, so it will not be very large, but here we will observe that the elements of group 15 showing the ionization enthalpy and elements of the group 15 showing the ionization enthalpy, there is a large difference between the ionization enthalpy of group 15. And why it is this? Here we see the carbon and here is a nitrogen. There is only the variation of one electron. Carbon has 2 electrons in the piece of shell, while the nitrogen having the 3 electrons in the piece of shell. So what will be happen here? If we will write the configuration of the carbon, what we'll observe, there will be 2 electrons in the p and the configuration of this 2p2, while the configuration of the nitrogen we will see that 2p3 and it has 1, 2 and 3. What do you observe here? It has the stable configuration and it has half filled p orbital. Due to the extra stability, the half p orbital, it required the more energy to remove this electron. Here you are seeing it is incompletely filled p orbital, so this electron can easily be removed and less energy will be required to lose one electron. So due to the extra stability of p3 configuration, or you can say half filled p orbital, group 15 elements have extra high ionization enthalpy in comparison to the group 14. Now see, if we move from top to bottom, from nitrogen to nitrogen, phosphorus, arsenic, antimony and bismuth, what do you observe? We observe that on moving from top to bottom, ionization enthalpy decreases because size of the atom increases. Nitrogen is mostly ionized, most high ionization enthalpy in these all elements, while bismuth has very less value of ionization enthalpy. It is clear to you that why the group 15 elements have extra ionization enthalpy in comparison to group 15, because of the extra stability of p3 orbitals. Now moving towards the next property, that is electronegativity. Tendency to attract electron, that is called electronegativity, and it depends upon the size of the atom as well as the number of valence electron. As we know that on moving from left to right, size decreases, so the group 15 elements have high electronegativity in comparison to group 14 and less in comparison to group 16. If we compare between two groups, that means the electronegativity of group 15 is larger than group 14 but smaller than the group 16 element. Nitrogen is the third most electronegative elements in all of the periodic elements. On moving from top to bottom, because size of the atom increases from nitrogen to bismuth, so electronegativity will be decreases. Dear student, today I have discussed the property of group 15 elements, in which electronic configuration and physical state, then ionization, enthalpy, melting and boiling points, and this electronegativity. And tomorrow we will discuss about the other topics of these elements. Okay, good night.